So welcome. On this video, we are back at it again on statistical interval, primarily on confidence interval, tolerance interval. So we have a problem that we are about to discuss. So stay tuned and don't miss out. This problem, a simple random sample of 50 adults is obtained and each person's 80% white blood cell count in cells microliter, take note, is measured. The sample mean is 4.63%. The population standard deviation is 0.54%. Construct the 95% confidence interval estimate for the mean red blood cell counts of adult where K is equals to 3. This is a very simple problem because we're only finding the 95% confidence interval, which is the lower and upper bounds, and the sample mean is given, K is given, and standard deviation is given. So for the solution, we are using the formula x bar plus or minus K multiplied by S, in which it is given that sample mean is equals to 4.63 plus or minus 0.3 times 0.54, in which it gives us a solution of 4.792 or 4.79 and 4.468. I did the math and calculation beforehand, so we can see the final answer and to let you know this without more further ado. So the conclusion is we find that the lower and upper bounds are 4.468 and 4.792. We are 95% confident that the above range covers the central 80% of the white blood cell count. Thank you. So welcome again on this video on statistical interval, which is topic about confidence interval, specifically on tolerance interval. So we give a background check on what is tolerance interval, which a tolerance interval covers a specified proportion of the population for a given confidence level. This gives us a pretty sure that the mean lies in here or it will fall in there. An example is find a tolerance interval that gives us two-sided 95% bounds on 90% of the distribution of packages of 95% lean beef. Assume the data came from an approximately normal distribution where the sample size is equals to 30. The sample mean is 96.2% and the sample standard deviation is 0.8%. Also, K is equals to 2.14. We use the formula of x bar plus minus K multiplied by the standard deviation, which is equals to 96.2 plus minus 2.14 0.8, which gives us the final answer of 94.5 and 97.9. What does this tell us? This tells us that we find that the lower and upper bounds are 94.5 and 97.9. We are 95% confident that the above average, or the above range covers the central 90% of the distribution of 95% lean beef packages. So we got this final answer.